Relation for displacement of M. M is foot of the perpendicular on x prime. From triangle OPM, OM by OP is cos theta. OM by OP is cos theta. OM is x. So x by r is cos theta, or x is equal to r cos theta. X is equal to r cos theta. Relation for displacement of n. From triangle ONP, sin theta is equal to ON by OP or ON by R, but ON is y, hence sin theta is y by r, so y is equal to r sin theta. But theta is omega t, hence y is equal to r sin omega t. Sometimes in simple harmonic motion we represent the amplitude as capital A, hence the relation becomes y is equal to a sin omega t. Y is equal to a sin omega t. Velocity of n. Velocity of n. We know that the velocity of n is v cos theta. V cos theta. But theta is omega t. Hence, velocity of n is equal to v cos omega t. But v is r omega. V is r omega. Now let us take the velocity as Vn is equal to v cos omega t. That is equal to v into square root of 1 minus sin square omega t. Since cos omega t is square root of 1 minus sin square omega t, Vn is equal to v into square root of 1 minus sin square omega t. Let us substitute v is equal to r omega and sin omega t is y by r. Y by r. Hence we will get Vn is equal to r omega into plus or minus square root of 1 minus y square by r square. When we take the square root, we will get plus or minus. Hence, r omega into plus or minus square root of 1 minus y square by r square. On simplification, we will get it as plus or minus omega into square root of r square minus y square. Plus or minus omega into square root of r square minus y square. This is another relation for the velocity of n. The velocity of n changes as it moves along y prime. As it moves along y prime. Let us take the relation for velocity. It is plus or minus omega into square root of r square minus y square. R square minus y square. Y is 0 when n is at equilibrium position, that is at O. When it is at O, y is 0. Hence, the velocity becomes omega into square root of r square or plus or minus r omega. Plus r omega represents in the upward direction, minus r omega represents in the downward direction. Then the velocity at extreme position, at the top position and the bottom position, at y and y prime, is r is equal to y. Hence, velocity becomes 0. Y square minus y square becomes 0. So, the velocity of n decreases from O to y. As the particle moves from O to y, the velocity of the particle decreases and it becomes 0 at y. While coming from y to O, its velocity increases from 0 to a maximum value. Variation of acceleration of n. We know that the acceleration relation for n is a is equal to minus omega square y, or a is minus r omega square sin omega t, minus r omega square sin omega t, or a is equal to minus omega square y. When the particle is at O, the acceleration, the displacement is 0, hence the acceleration is 0. Acceleration will be 0 when the particle is at O. When it is at an extreme position at y, then acceleration will be equal to minus omega square y. Minus omega square y. If you take the amplitude as a instead of y, it becomes a maximum is equal to minus omega square a. Minus omega square a. This is maximum acceleration. So acceleration is 0 at equilibrium position and it is maximum at extreme positions. So the acceleration will be increasing from O to y and it will be decreasing from y to O, that is in magnitude. But its direction is always towards O. Maximum and minimum values of acceleration. Maximum and minimum values of acceleration. The relation for acceleration is A is equal to minus omega square y, minus omega square y, where y is the displacement and omega is angular frequency. So acceleration depends on y because omega is a constant. So when y is minimum, acceleration is minimum, and when y is maximum, acceleration is maximum. At equilibrium position O, y is equal to 0. So acceleration is equal to 0 at equilibrium position. Y is equal to capital A, where A is the amplitude at extreme positions. At extreme positions, y is equal to A. Therefore, acceleration is equal to minus omega square A at extreme positions. Hence, the magnitude of acceleration is maximum at extreme positions and it is minimum at equilibrium position. Maximum at extreme positions and minimum at equilibrium position. Relation for omega. Relation for omega. Acceleration A is equal to minus omega square y. Let us neglect the sign and take the magnitude. Then we will get A is equal to omega square y in magnitude. So omega square is equal to A by y. Omega square is equal to A by y. So omega is equal to square root of A by y. Omega is equal to square root of A by y, where A is acceleration and y is displacement. Angular displacement. If the particle is moving with uniform or constant angular velocity omega, then angular displacement is equal to omega into t. Omega into t. Let us try to have an understanding of the values of angular displacement when the particle is at different positions. When the particle is at A, that is the starting point, its angular displacement is 0. As the particle moves from A to B along the circumference, so the radius vector will be rotating about O. Then the angular displacement will be increasing. When the particle comes to B, the angular displacement becomes pi by 2 or 90 degrees. At B, the angular displacement is pi by 2. When the particle comes to C, the angular displacement is pi. When the particle comes to D, the angular displacement is 3 pi by 2. When the particle returns to A, the angular displacement becomes 2 pi. Like this, the angular displacement will be increasing. Time period. It is the time taken to complete one revolution by the particle. The time taken to complete one revolution by the particle is called its time period. By the time the particle completes one revolution, the radius vector sweeps an angle 2 pi. The angular velocity is omega. Hence, the time period t is equal to 2 pi by omega. The time period capital T is equal to 2 pi by omega. But we know that omega is equal to square root of A by y. Therefore, T is equal to 2 pi into square root of y by A. It can be understood as T is equal to 2 pi into square root of displacement by acceleration. Y is displacement and A is acceleration. Hence, the time period of the particle in simple harmonic motion is given by T is equal to 2 pi into square root of y by A or 2 pi into square root of displacement by acceleration. Relations for y, v and A. Displacement, velocity and acceleration of the particle in simple harmonic motion. The displacement y is equal to r sin omega t. R is amplitude. The relation for velocity is omega into square root of r square minus y square. V is equal to velocity square root of omega into square root of r square minus y square. It has another relation. V is equal to r omega cos omega t. Acceleration A is equal to minus omega square y. Acceleration A is equal to minus omega square y or minus r omega square sin omega t. Minus r omega square sin omega t.